Hey everybody, Mr. Bowman here. This video is in 2.7 Calculus and we're focusing on all the merit questions for the 2024 exam. Just a reminder, these are all past NZQA exam questions. I've just kind of compiled them all in one place for you. So if you are interested in more merit questions for this calculus paper, check out the link that I put in the description to this video. So let's get straight into question number 51. And there were only 4 merit questions in this exam, so it ended up being quite nice. So we've got a function here. We've been told it passes through this point here, and we've been asked to find the original function. And I suppose to note, the function we've been given here, that's the gradient function. So we need to integrate this and then use this information here to find that out. So I guess the first thing is this coordinate here, that tells us a bit of information about x and y, which we're going to be able to use later on. So it tells us that x is equal to 2, and it tells us that y is equal to 36. So we're going to need that there. So the first step is let's integrate this expression here. So I'm going to jot down the whole expression because I find when I jot it down, I minimize all the math errors that I do. So we've got 12 minus 4x plus 6x squared. I now need to integrate this to get fx. So 12 will integrate to 12x. 4, so remember we've got a power of 1 there currently. So we're going to go minus 4 divided by the current power plus 1. And then we've got x, and then the current power plus 1. And I learned a trick, or memorized this trick. Whatever the denominator is, that's kind of what the new power is. And then we've got plus, same over here, 6. So current power, which is 2, plus 1, x. And then we've got 2 plus 1, and then we've got plus c. And I can just simplify that expression a little bit there. So we've got 2x squared, sorry, 12x. 4 divided by 2 is 2, so it's going to be minus 2x squared. And then we've got 6 divided by 3, so it's going to be 2x cubed. So plus 2x cubed, and then we've got plus c. So I'm liking what I've got here. I've got the whole expression. The only thing is I don't have c, so I haven't got the full function yet. So what I need to do now is substitute in these values to calculate algebraically what c is. So I know this entire thing here is my function, so I should set it to 36. So 36 will be equal to 12 times x, which is going to be 2 times 2 minus 2 times 2 squared plus 2 times 2 cubed, and then plus c. So I've taken up, put in the y, and I've substituted in the 3 x's, all being 2. I can now go ahead and evaluate what all those numbers are. So 36 will be equal to, what's that, 24 minus 8. So 2 cubed is 8 times 2 again is 16, so plus 16 plus c. Let's calculate what all this comes to. So 24 minus 8 is 16, plus another 16 is 32. So we've got 36 is equal to 32 plus c. I'm going to move that 32 over to the other side. So subtract 32 from both sides, so c is equal to 4. And from that, I can now state my final equation. So that means fx is equal to 12x. So I'm copying this line here, except I'm adding in the c, minus 2x squared plus 2x cubed, and then it's plus 4 at the end. So that's that c value I've added in. So next question, question number 52. And question 52 is one of the graphing questions. And these questions are typically poorly done, in my opinion. So the classes I've taught typically don't do that well in these ones. So I've developed a few ways to kind of help promote how to approach these questions. So I guess the first thing to note is figure out what function you've got here. And we've got the original function. And we've been asked to sketch the gradient function. So what we need to do is from start to finish, we need to analyze this function, this cubic, to then figure out, well, what's the gradient going to be? So I guess the first thing to note, let's break it down into a chunk. So here's the start point, and we can see from here to here, it is decreasing, right? So that means this area here, we're going to have, I'll put a minus sign there, we're going to have a negative gradient. At the turning point over here, a turning point, we know that a gradient is equal to 0 at that particular point. And then from here to the next turning point, well, we can see that graph is all going upwards, so it's all positive. And then finally, not finally, but now we've got a new turning point, which is 0. And then finally, from here onwards, we can see it's all going downhill again. So that means it's negative. So I'm breaking down my function to find out what it would be. So because it's a negative gradient, that means in this area here, the gradient function is going to be below the x-axis. And in this area here, the the gradient is positive, so it's going to be up here in the positive area of the axis. And then finally, again, we've got a negative gradient here, so that means in that section there, it's going to be below the x-axis. So I guess the next thing to note is that it goes from negative to positive as it passes through this turning point, right? So the first thing we need to do is these turning points here, we need to go back down to the x-axis because that's when x is 0, or when y is 0, we're going to do that. So we go down here, so our parabola, so our gradient function, it must go through that point there, and again, same thing here, going down there. So the parabola must go through those points. We know in between it, it's going to be positive, so it's going to look something like that. So a cubic, remember, is an x squared. So this one's actually a negative cubic. And if you differentiated a negative cubic, we would have got to like negative 2x, or so negative 3x squared. So what we've got is we've got a negative parabola. So basically we've got a line that's coming up here, because it's a negative parabola, right? And this area represents this decreasing area up here. Then we hit the turning point, and then we go across like this. That represents this positive area here, because it's all in the positive territory of the axis. And then finally it goes down. Oh, I should make it more symmetrical. It goes down like that. And this is negative, because that represents the negative area of the axis. So hopefully you can see how that one works. So these ones are a bit annoying, but using my graph skills and breaking down the gradient of the original function, I can kind of see what's going to happen here. Moving on to question number 53. So we've got the equation, so we're trying to find the equation of a tangent for this particular function at this particular point. So I guess the first thing to note is the point gives us a bit of information. At that point there, like a previous question we did in this video, it tells us that x is negative 2, and it also tells us what y is, which in this case is 3. So that's the first thing here. So I guess to reconcile what we're trying to do, this equation of a tangent, remember the equation of your straight line, y equals mx plus c? We need to figure out, well, what's the gradient going to be at that point? And we can do that through differentiation and finding the gradient function. And we also need to find the constant. So that's where we're aiming for. So we can't really find the constant. We've actually got to use algebra. So we've got to use algebra to figure that out. But we can use the gradient function to find out that m value. So using the gradient function to help us with that. So using the gradient function. So let's differentiate this function here to find that gradient function. So we've got fx, this is me rewriting the question, is 3 minus 12x plus 3x cubed. Let's differentiate this function. So that 3 will differentiate to 0, so we can ignore that. Negative 12x differentiates to negative 12. And then 3x cubed, so that's going to be the coefficient times the power. So what's that? Going to be 9. So it's going to be plus 9x squared. So that's my derivative. So I should write f dash x there, shouldn't I? I'm now going to find the gradient at this point. So I need to find the gradient when x is equal to negative 2. So f dash negative 2 is what we're trying to find out here. So that's going to be negative 12 plus 9 times negative 2 squared. So calculating this, negative 2 squared is 4. 4 times 9 is 36 plus 12, or negative 12, that's going to be positive 24. So I've now got the gradient. So writing down my function here, my function is going to be y is equal to 24x plus c. That's where I'm currently at. I still don't have this constant value. And that's when I'm going to use this x and y again. So if I substitute in y, substitute in x, c will only be the letter left over. I can go ahead and use some algebra to figure that out. So let's put that in. So y is equal to 3. So 3 will be equal to 24 times negative 2 plus c. So 3 will be equal to negative 24 times negative 2 is going to be negative 48 plus c. Moving that negative 48 over to the other side by adding that to both sides. 51 is equal to c. I've now got my constant. And now that I've got that, I can state my equation. So my full equation, y is going to be equal to 24x plus 51. So we're now on to question number 54, and this is the final of the 4 questions, or the 4 merit questions for this exam. And this is a kinematic style question. So we've got a truck is waiting at a red traffic light. So because it's waiting at a traffic light, we know a bit of information there. We know it's still, so it's got no velocity. We know it hasn't moved, so the displacement is 0. So we might be able to use that information later on. When the traffic light turns green, it begins to accelerate at this here. So this is actually part of our formula. So our acceleration in terms of time is equal to 0.64 until it reaches its top speed. Use calculus to find the distance the truck has traveled until it reached its top speed. So I guess the first thing to note is we're trying to find the distance, which is displacement. So we're going to need a displacement formula. So we're going to need to integrate twice to do that. So remember, if you've got your displacement, your velocity, your acceleration, if you're going down our chain, I'll put d there for differentiation. If you're going up our chain, which we are, because we've got acceleration, you are integrating. So we need to integrate both of these. So if we integrate the acceleration, that will get us the velocity, and that there is simply going to be 0.64 t plus c. We now just need to figure out what c is, and this is when that bit of information about waiting in the traffic light comes in. So when you're waiting at the traffic light, we know that the velocity will be equal to 0, and we know that no time has passed because you haven't started accelerating yet. So we're going to substitute that in to find c. So we know that 0 will be equal to 0.64 times 0 plus c, which means c is equal to 0. So from that, we've got our full velocity equation. There's no constant. It's just 0.64 t. I can now do the same thing here. I need to integrate another layer to get my displacement formula. So my displacement in terms of t is going to be equal to, remember, we're integrating, so we need to know that there's a power of 1 there. So it's going to be the coefficient 0.64 divided by the power plus 1, t power plus 1 plus c. And simplifying that, so that's going to be 0.32 t squared plus c. And then the same thing again, we need to find c, and at the traffic light, before we even started, 0 time had passed, and we had traveled 0 distance. So we knew that d0 t is 0, and that actually tells us that the constant there was 0 too. So let's just write down my final equation. So my displacement in terms of time, 0.32 t squared, and there's no constant there. So the issue we've got is, so we need to find the time, also the displacement or the distance traveled. And the only way we can do that is by knowing the time at the point we're finding out, which we don't have because we were asked to find out the distance traveled once it reached the top speed. So what we need to do is we need to link the top speed back to the velocity formula to solve for time. So what would the time have been at that point? So as I wrote before, so our velocity in terms of time is equal to 0.64 t. We're interested in the velocity of 25. So when is 25 equal to 0.64 t? We can use algebra to find t here, right? So we're going to go divide by 0.64, divide by 0.64. So when is t equal to 25 divided by 0.64? And when you get that, t is equal to, we've got a bit of a decimal scenario here. So I got 39.0625. And I didn't need to round that, so there's no rounding to state. So I've now got the time in which I'm interested. So I can now plug that into my displacement formula to find the distance that would have traveled. So I'm trying to find the displacement when time was 39.0625. And that there is going to be equal to 0.32 t squared, and we're going to substitute in t, 0.32 times by 0, or no, not by 0, by 39.0625 squared. Again, plug that straight into the calculator, and it is a bit of a messy number, so we're going to have to do some rounding here. So I got 488.3 meters, which are my units, and I rounded it to 1 decimal point. So hopefully you found this 2.7 calculus video useful. Just a reminder, there's a whole heap of more questions like this in the link. All the past NZQA paper ones are put in one place for your convenience.